Good afternoon. We are going to be going over the 1.2 notes, which for us will be the distributive property and combining like terms. The learning target for today is I can simplify expressions using the distributive property and combining like terms. So the notes that we did last time, which were our notes 1.1, talked about how to simplify expressions, and we learned how to do that by using the order of operations / PEMDAS. Today we're going to be talking about continuing to simplify expressions, but we are going to be using other methods if PEMDAS doesn't work, okay, which will happen in this case. So we have some different vocab today. The very first vocab word we have is variable, and a variable is a letter that represents an unknown value. So this is a letter that represents an unknown value. The most common variable that you will see is X. We will often use Y as well, and really any letter can be used as a variable. Those are just the two most common ones that we use. The next vocab word is a coefficient, and a coefficient is a number that is multiplied by a variable, and I'll give you an example of that. So a coefficient is a number that is multiplied by a variable. So if I have something like 5x, x is my variable, and 5 would be considered my coefficient. So that is a number being multiplied by a variable. We put our coefficients in the front of our variables, so you will always see 5x. You will almost never see x times 5. A term is going to be a letter or a variable, a number, or a combination of the two. Terms are going to be separated by either addition or subtraction. Ooh. So for example, I could say that 5xy squared is considered a term. I've got a 5, which is my coefficient, and then I've got x, which is a variable, and y squared, which is a variable with an exponent. But nothing is being added or subtracted within those three things that I have in there. So this is going to be a single term. If I gave you the example of 3x plus 5y, I now have two terms. 3x is a term and 5y is a term. Those two things are separated by an addition sign. So therefore you have two different terms. Over here, there was not an addition or subtraction sign anywhere within my 5xy squared. So it is a single term. Over here, you've got two terms. I could do another example. I could say, negative 12 minus 5x plus 2y. That's going to be three terms. You've got a term here, a term here, and a term here, and those are separated by addition and subtraction signs. So those are going to be three terms. And remember that terms do not have to contain a variable. They just can contain a variable. They can either have a variable, they can be just a number, or they can be both a number and a variable together. Like terms are terms that have to have the same variable as well as exponent. So like terms are going to have the same variable, and again, they also are going to have the same exponent. I almost wrote like terms again. Both must be the same. So I'll give you an example. 5x and 5x are like terms. They both have an exponent of 1, and they both have a variable of x. The number in front doesn't really matter. Whoopsies. I could say that this is negative 2x to the first, and 5x to the first and negative 2x to the first are considered like terms. Let's do another example. I could have 2xy, and I could have negative 7xy. Those are also considered like terms. Both of those terms have an x to the first and also a y to the first. So those are considered like terms. That's good. If I had 2xy and then minus 7x, those are not going to be like terms. Even though they both have an x in common, my first term has a y, my second term does not. That's just a negative 7x. So because that negative 7x does not also have a y with it, those would not be considered like terms. Let's do another example. This will be the last one. I have 5x and then negative 7x squared. These are not like terms. They have the same variable, which is the first rule that we have to have. They have to have the same variable, but my first term is x to the first and my second term is x squared. So although they have the same variable, they do not have the same exponent, so this would not be an example of like terms. All right, the distributive property. It is a property that allows us to simplify an expression by using the operation of multiplication. Let's do blue. So the distributive property is going to look something like this. And I'll do the actual example later, but you will see parentheses when you use the distributive property. So we don't talk about the distributive property unless we have a set of parentheses somewhere. Okay, so notice that you have a number on the outside of a set of parentheses. I cannot simplify the inside of those parentheses. So in order for me to simplify, because I have to simplify, I have to get rid of those parentheses, we will use something called the distributive property. I'm not going to do it right now, but I will do that for you later. But that is what we would see when we were to use the distributive property. Okay, the next word that I have here is a polynomial, and a polynomial is any expression which consists of variables, numbers, and exponents. So we've got, I'm going to do light purple. Variables. What did I say? Variables, numbers, and exponents. So what I showed you up here, like that is considered a polynomial. That is also a polynomial, but it has a very specific name. Woo. This is also a polynomial, and it also has a very specific name to it. But notice that these are letters, variables, numbers, and exponents. So polynomial is kind of an umbrella word, and we will actually use polynomial to describe any kind of expression that has these different types of terms in them. However, you can have specific types of polynomials. For example, you can have a monomial, and a monomial is a polynomial with one term. Okay, that was the first thing that I showed you up here. This 5xy squared is considered a monomial. It is one term. Let me erase this so I can show you. So this would be like 5xy squared. Even though it looks like there's more going on, that is just a single term. A binomial is a polynomial with two terms. That would be like the second thing that I showed you up there, 3x plus 5y. You've got one term here and one term here. Here it's just a single term. And then I'm sure you can guess what comes next. A trinomial is a polynomial with three terms. That was the last thing that I showed you up there at the top. We have negative 12 minus 5x plus 2y. There's a term, there's a term, there's a term. As a reminder, terms are separated by addition and subtraction signs. There are no addition and subtraction signs in a monomial. A binomial will have one, either addition or subtraction. A trinomial has three terms and will have two signs, either both addition, both subtraction, or one addition, one subtraction. So the way that you can think about this, mono for me is a little bit hard to remember, but I know that bi is like a bicycle, and a bicycle has two wheels. Oh geez, let's see, there's a seat. There are handlebars. So a bicycle has two wheels. Bicycle, binomial, okay? A trinomial is what you see little kids ride around on. It's a tricycle. It's got three wheels. We got a wheel here, a wheel here. I do not know what tricycles look like. There's a wheel here. There's some handlebars. There's a seat. Good enough. This has three wheels. So a trinomial has three terms. A triangle has three sides. Those are just ways that you can remember the differences between binomial, trinomial, and monomial. All right. In this next section, we are going to describe each of these polynomials as either a monomial, a binomial, or a trinomial. So when I look at this first polynomial, I have a term and then a plus sign. So then I got to start over again. And then I got a term and then a minus sign. And then I got to start over again, and then I've got a term here. So I've got a plus sign and a minus sign, and I have three things that are underlined. So this will be a trinomial because there are 3 terms there. When I look at my second example, my second polynomial, although there is a minus sign in the front, I do not have an addition or a subtraction sign separating any of the variables or that coefficient in front on the inside. So I actually just have a single term here. So this will be a monomial. And then lastly, I have a term and then an addition sign, and then I have to start over again, and I have another term. So I now have a binomial. And there we go. I've labeled each as a monomial, binomial, or trinomial. All right, in this next section, I need to create terms that are like the provided term. So if you look at this first example, I need to write another term that is like 15x squared. Well, anything that is an x squared will be like 15x squared. So I can say negative 3x squared, negative 1000x squared. You could have really anything, I don't know, 7x squared, 2.5x squared. Notice that all of these are ending in an x squared, which makes all of them like 15x squared. If I move over to example 2 has an x to the first, a y to the third. So any term that I write that is like this has to also have an x to the first and a y to the third. So I could do negative 5x to the first, y to the third. That's a like term. I have 12x to the first, y to the third. I have negative 15,001 x to the first, y to the third. Because all of these end in x to the first, y to the third, they are like x to the first, y to the third at the beginning. Number 3, negative 6. Negative 6 is just a number, so any number without a variable with it would be considered like. This doesn't have a variable, so none of my other problems can have a variable. And I don't have an exponent, so none of my, I mean, I do technically have an exponent, but it's not attached to a variable. So if I just have a single number, then any other number is going to be considered like that. And then lastly, I have I have just an x to the first. So I can have anything that is an x. I could just do x to the first. I could do 12x to the first. I could do 90x to the first. I could do negative 15x to the first. All of these end with an x to the first, so they are all considered like negative 3x to the first. The numbers in front don't matter. It doesn't matter if they're positive, if they're negative, if they're a decimal. The thing that matters is they must have the same variable and they must have the same exponent. This next section wants us to simplify the expressions by combining like terms. I need to label the final answer as either a binomial, monomial, or trinomial. So when you look at what we have here, we are going to combine our like terms, and we are going to do this by, I like to circle or underline or squiggle any terms that I consider like. So I'm going to start with blue. I'm going to just grab something. I have a 5x to the first. So any other term that has an x to the first would be considered like 5x to the first, and I can combine them. And if you look at the rest of my problem, I only have one other x to the first term, and that is 3x to the first. Now, when you are grabbing terms out of an expression, you need to grab the sign that is in the front of that term. So that is not just 3x to the first, that is a plus or a positive 3x to the first. So I have to grab this whole thing. I don't have any other x to the first term, so now I'm going to move on. And the next thing that I run into is this 12. But remember that I have to grab the sign in front, so that's going to be a negative 12. 12 is just a number, so any other just numbers that I see are going to be like negative 12, and I'm going to also circle it in green. And that's going to be this plus 2. So now I get to add my like terms together. And when you add like terms, because they are like terms, the thing that goes at the back has to be the same thing that we started off with. If we have a 5x to the first and a 3x to the first, then when I add them together, it has to end in an x to the first power. So 5x to the firsts plus 3x to the firsts give us 8x to the firsts. And then I'm going to go through and I'm just going to add our numbers together. I've got a negative 12 plus 2, which adds to get me negative 10. So when I put all of this together, I have an 8x to the first minus 10, and that's going to be my final answer. I cannot combine my 8x to the first and my minus 10 because one has a variable and one does not. Now, I have two terms here, so this is going to be considered a binomial. Now I'm going to move on to this guy over here. I always start at the beginning. I have a negative 8x squared, so any other term that ends in an x squared, I will be able to combine with my negative 8x squared. And if you look, the thing next to it is a positive 3x squared. The next term that I have is a positive 5x, but because it is not an x squared, I can't combine it with the other two things that I have. So I'm just going to circle that in green. Nothing else in my expression is just an x to the first power, so I'm going to move on. The last thing that I have is a negative 6. There is nothing else that is just a number in here. So what I'm going to do is I'm going to combine these together. Remember that when you combine them together, the thing at the back, that x squared term, has to say x squared. And then I just add what's in front. Negative 8 plus 3 is a negative 5. I'm going to bring down my positive 5x to the first. It doesn't have anything to get added with. And then I'm going to bring down my negative 6 because that also doesn't have anything to get added with. And my final answer is going to be exactly what I have here. Now, when I look at this, hopefully you can see that I have 3 terms, and this will be a trinomial. All right, now we're getting into the meat of the notes today, and it is going to be over the distributive property. We use the distributive property when we cannot combine terms inside of parentheses like the example below. So yesterday, or whatever day it was, when you learned about 1.1 PEMDAS, PEMDAS tells us that we must simplify parentheses first. The problem is I might end up with something that I cannot simplify. If you look inside of my parentheses, I have an x and a negative 2, but x and negative 2 are not like terms. I cannot add them together, but I still have to get rid of my parentheses. So what we do is something called the distributive property. And what the distributive property tells us is if you have a number in the front or anything in the front of a set of parentheses, you can actually distribute or take that number or that variable or whatever's on the outside and multiply it by every single term on the inside. So I can take this 5 and multiply it by this x. I'm then going to have to also take the 5 and multiply it by this negative 2. Because remember that whenever you have an expression or a term, the sign in front of it is what goes with it. So that's what the distributive property is. So that's what this is saying, okay? You can do a times b, which gets you a times b, and then you go back and do a times c, and that'll get you a times c. You have done this before. I believe you did it in like 6th grade. You may have done it in 7th and a little bit in 8th, but you learned about this the first time in 6th grade. So we have to simplify the expression by using the distributive property. We're going to label the final answer as a monomial, binomial, or trinomial. So let's start with number 1. I cannot combine my x and my 1 together because one is a variable and one is not. They are not like terms, so I cannot actually take care of the parentheses. So what I need to do is take this negative 3 on the outside, and I need to multiply it by both the x and by the plus 1, but we're going to do that separately. Negative 3 times x is negative 3x. They just get squished together. I know you can't see me, but I just clap my hands together. They just get squished together. And then I'm going to go back and do negative 3 times, this is a positive 1. Negative times a positive is a negative. Negative 3 times positive 1 is a negative 3. I cannot combine those things together. Whoa. I cannot combine those things together because one has an x and one does not. So this is going to be my final answer. There are 2 terms here, so this is a binomial. What happens, do you think, if there is just a negative sign in the front of a parenthesis? There's actually an invisible negative 1 there. So I'm going to be taking this negative 1 and I'm going to distribute it on the inside of my parentheses. Remember that the distributive property is multiplication. Negative 1 times x is negative 1x. You can put the 1 there if it makes you feel better, but you do not have to. It is not a requirement. The negative must go there, though. Then I will do negative 1 times, this is a negative 4. A negative times a negative is a positive. So negative 1 times negative 4 is a positive 4. I cannot combine those 2 terms together. They are not like terms. That becomes a binomial. Let's come over here. There's a lot going on the inside of my parentheses, but none of the things that are going on the inside of my parentheses are like terms. I have a 2x. And then I have a 6z. So although they both have a variable, the variable is not the same variable, so I can't combine them in any way. And then I have a negative 4 at the back It's just a number. I can't do anything with it. So what I'm going to have to do is distribute this 1/2. Okay. So when you multiply a fraction by a whole number, what happens is you are going to multiply the number on the top of your fraction, your numerator, by the whole number. So this is going to be 1 times 2, and then you're going to divide that by whatever's in the denominator. Okay, 1/2 times 2 is just 1. Whoopsies. But what is attached to my 2 over here in x? So 1/2 times 2, you can use your calculator if you need to. 1/2 times 2 is 1x. You do not have to put the 1 there. You can just put an x there. Then I go back and do 1/2 times 6z. That's going to be 6 times 1 divided by 2, which ends up being 3z. I'll write this back down here so you can go back and look if you want. And then I go way back over here. Now, don't forget, this is a negative. So I've got -4 times 1 divided by 2. And you end up, when you do that, let me move this down a little bit. When you do that, you end up with a -2. When you look at your final answer, you have an x and a z and a number without a variable. None of those are considered to be like terms, so we're going to go ahead and box that. And that is going to end up being a trinomial. There are 3 terms there. Okay, now we have something that looks like this. I actually have 2 different distributive properties that I'm doing here, okay? This 7 that's in front is going to get multiplied only by what's in the parentheses that the 7 is touching. So the 7 is only touching the parenthesis that contains x and +4, so I'm only going to focus on distributing the 7 to those 2 terms. So 7 times x is 7x, and then 7 times 4 is a +28. Then I'm going to move on to my second set of parentheses that has a -6 in front. So I have to distribute the -6 to both of these terms. -6 times a +3 is a -18. And then -6 times -y is a +6y. Now we don't have any more parentheses, which is great. We're partially through simplifying. We always have to check to see if we have any like terms that we can combine. I have a 7x, but I have no other x's in my problem. And I have a 6y and no other y's in my problem. But hopefully you guys can see that you have a +28 and a -18. Those are like terms because they are just numbers. They don't have any kind of variable with them, and numbers by themselves are always going to be like other numbers that are by themselves. So my final answer will be 7x plus 10, because +28 minus 18 is a +10, plus 6y. None of those 3 terms are like, so I'm just going to box my final answer. And the order in which you put these in your final answer doesn't really matter. You could have done 7x plus 6y plus 10, or 10 plus 7x plus 6y. It really doesn't matter to me. I don't think it's going to matter to whoever your teacher is either. But no matter what, we end up with 3 terms, and we have a trinomial. Okay, here we go. Number 7 is very similar to number 3, where we have a fraction and a whole number. So I'm going to start by multiplying 4 by this fraction. You multiply the whole number by whatever the top, the numerator of your fraction is, and then you divide it by the denominator of your fraction. So that's going to give me 12 divided by 4, which is 3. So this will be 3x. Don't forget that there's an x up there. And then we're going to do 4 times a +2, which is a +8. Now, that 4 is only touching the first parenthesis, so we are done with the first parenthesis, and now we are going to distribute a +5 to this fraction. Whole number times numerator divided by the denominator. 5 times 4 is 20. 20 divided by 5 is 4. Don't forget your x. And then 5 times -1 is a -5. Now that we are here, we are going to combine our like terms. I've got a 3x and a +4x. Those are like terms. I'm going to combine those to get me a 7x. And then you've got an 8 and a -5. So when you combine those 2 things, you get a +3. So your final answer will be 7x plus 3. Sorry if you hear dogs barking. And because there are 2 terms left here, you will have a binomial. Okay, Okay, so now what we're going to do is we are going to do two different examples of simplifying just good old expressions without variables in them. But I'm going to show you that even if you can do PEMDAS, you don't have to do PEMDAS, okay? So I'm going to just start with letter A, start, okay? You have 3 parentheses 4 plus 2. Because I don't have any variables, I can actually simplify this using both order of operations / PEMDAS and the distributive property. I'm going to do each of these separately and show you what that's going to look like. So I'm going to start with the order of operations. The order of operations is PEMDAS, so I'm going to follow PEMDAS. First thing I need to do is simplify my parentheses, which is 4 plus 2. 4 plus 2 is 6, and then 6 times 3 is 18. Now I'm going to look at that exact same problem, but instead of using the the order of operations, I'm going to use the distributive property. I'm going to start by distributing that number on the outside of the parentheses by everything on the inside of the parentheses. So this is going to be 3 times 4, which is 12. And then 3 times a positive 2, which is a positive 6. 12 times 6 is 18. Now, when you simplify the same expression these two different ways, you should actually end up with the same answer. Notice that when I did the order of operations and the distributive property, I got 18 for both of my problems, which is a really good way for you to check to see if you're doing it right. But this also just goes to show you that oftentimes in math, there is going to be more than one way to do something. If we tell you to do it in a specific way, you should do it in this specific way. But if we don't tell you how to do it, then just do it in the way that makes the most sense to you. Everybody's brains work differently, and one thing that might work better for me might not work better for you, and that's okay. All right, let's check out letter B. We're going to do the same thing with this problem. We are going to start with the order of operations. Miss PEMDAS, please excuse my dear Aunt Sally. We have 2 minus 4 times 7 plus 3. So I'm going to follow PEMDAS, and the first thing I'm going to do are my parentheses, which is 7 plus 3. 7 plus 3 is not 4. What am I doing? It's 10. Okay, now with PEMDAS, that's my dog, we don't have any exponents, but we actually do have a multiplication right here. We have negative 4 times 10. Negative 4 times 10 is a negative 40. And then 2 minus 40 is kind of gross, but it's negative 38. Okay, so when I do the distributive property, hopefully I also get a negative 38 to ensure that I did this correctly. So now we're going to do 2 times 4, 2 minus 4 times 7 plus 3. Okay, we have to be careful when we do the distributive property here. So when I do the distributive property, I have to distribute whatever is physically touching the parentheses, not just what's in front of the parentheses. So what is physically touching the parenthesis right now is negative 4. That 2 is just hanging out by itself. It's not going to be very useful to me. So I'm going to start by doing negative 4 times 7, which is a negative 28. Now before I move on, I'm going to bring down this 2 that I didn't do anything with. I have to go back. Negative 4 times a positive 3 is a negative 12. I did not distribute the 2. I only distributed the thing that was touching the parenthesis, which in this case was negative 4. So now I'm going to do 2 minus 28. I'm going left to right because now I can follow PEMDAS. That's going to be a negative 26 minus 12 is a negative 38. And I got the same thing again, which just shows me that I did this the right way using two different methods. All right, and now we have an application problem. It says an artist uses a rectangular canvas which has a length of 4x plus 3 and a width of x plus 2. Draw a picture of the canvas and label all 4 sides. So the first thing that it tells me is that this artist is using a rectangular canvas. So I'm going to draw a rectangle. Crazy. And whenever you think about a rectangle has the same length on top and bottom and the same width on the right and the left. Like that is just a property of a rectangle, is that it has the same value on top and bottom, and then the same value on the left side and the right side. So it doesn't actually matter where you choose to put these things. I always make the length the top and the bottom and the width the right and the left. So I'm going to say that the length is 4x plus 3, but whatever I do to the top, I also have to do to the bottom. And then it tells me that it has a width of x plus 2. So that means that the sides are going to be an x plus 2. So I drew a picture of the canvas, which it told me to do, and I labeled all 4 sides, which it told me to do. Now, what I need to do at this point for part B says find the perimeter of the canvas. So when you find the perimeter of any shape, all you're doing is adding the sides together. So I'm going to do 4x plus 3 plus x plus 2 plus 4x plus 3 plus x plus 2. So I've got 4x plus 3 plus x plus 2 plus 4x plus 3 plus x plus 2. I'm not going to set it equal to anything. We haven't done equations yet. We've only done expressions. And now that I'm here, guys, it's just combining like terms. So I'm going to start by looking for anything that is like 4x. I've got a positive x. Remember that they just have to have the same variable and the same exponent to be like. That's an x to the first, and this is an x to the first. So I'm going to go ahead and add all of my x's together. Okay, remember that like terms have to end with the same thing that they started with. If all of these are x to the first, then when I add them all together, my final part of this must also be x to the first. So this is a 1, and this is a 1. So you've got 4x plus 1x plus 4x plus 1x. That's 8, 9, 10. That is 10 x to the firsts. And then I've got a positive 3, a positive 2, a positive 3, and a positive 2. So when you add all of those together, you get a positive 10, because 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 2 is 10. My brain stopped working for a second. So I've got 10x plus 10, and that is the perimeter of my rectangular canvas. All right, everybody, that is it for these notes. As always, if you have any questions or need any more assistance, please go see your teachers during their scheduled tutorial times.